Hello. So we are going to continue vertical projectile motion, and we are going to attempt the question 3 of our exam paper, November 2017. This is a grade 12 question. The question states, if we can briefly go through it, stone A is projected vertically upwards at a speed of 12 meters per second from a height h above the ground. You can ignore the effects of air resistance. So let's attempt question 1. Calculate the time taken for stone A to reach its maximum height. And they also give us a clue on how to continue this question. They say, at the same instant that stone A is projected upwards, stone B is thrown vertically downwards from the same height at an unknown speed that we call v. In the diagram, they show us what or how we should visualize this. So A is being thrown up at a speed of 12 meters per second, and B is thrown down at a number v meters per second. So the initial speed that A travels at is 12 meters per second, and the initial speed that B travels at is v meters per second. So as you note, if you are going to indicate up as positive, then this will be 12 meters per second, and this will be minus v meters per second. If you choose down as positive, then those directions will then be vice versa. So this will then be positive v meters per second, and this will be negative 12 meters per second. So when you attempt question 3.1, because question 3.1 focuses on ball A, and they want us to calculate the time taken for our stone A to reach its maximum height, we need to remember that as the ball goes up, because gravity is acting on the ball in the opposite direction, the ball will slow down. Eventually, it will reach 0 meters per second. And once it reaches 0 meters per second, it will then change direction and fall down. So we can then safely say that the initial velocity is 12 meters per second, and our final velocity is 0 meters per second at the maximum height. Now we have two sets of information that we can use for our equation. We have our initial velocity and our final velocity. The question then wants us to determine what the time would be in order for A to reach its maximum height. So for the time being, t will equal to question mark. We can use one of three equations. In here you can see that our final velocity and our initial velocity is available. Our acceleration in this instant, because it is vertical motion, our acceleration will then be the same as gravity. So you can then change the A into a G. And then the time is what we need to find. And then, because we chose this equation, our final velocity is equal to our initial velocity plus our gravity times the difference in time. We then substitute all of the information into this equation. As we stated, in this situation I've chosen down as positive. So I've chosen down as positive, which makes our initial velocity negative 12. We don't bother to put a negative in front of 0 because this won't matter. Our gravity, according to the question paper, is 9.8 meters per second squared. And our time remains unknown because that is what we need to find. Then we do isolation of our time. remember that when you bring 12 over to the other side, so when 12 is brought over to the other side, our equation will look like this. And then because this is 9.8 multiplied by time, it is multiplied by on this side, it becomes divided by on the other side. So therefore our answer will then be times equal to 1.22 seconds. For question 3.2, we have to consider when stone A reaches its maximum height, the speed of stone B will be 3v. Using this information, calculate the speed v with which stone B is thrown downwards. Question 3.2 we have drawn as a diagram. Remember, it is easier to depict the question through some visual representation, and in this case I wrote down that our ball B that is being thrown downward, the initial velocity is v meters per second as indicated in the question. They also say that we should calculate the speed v with which the stone B is thrown downwards. A clue that they give us is when the stone A reaches the maximum height, the speed of stone B is 3v. What do we know from this? We know that it took A 1.22 seconds to reach its maximum height. And in that time, B started off traveling at v meters per second. And at the point when A reached its maximum height, which is t is equal to 1.22 meters, this should actually be seconds. So when the time reached 1.22 seconds, that indicates that ball A reached its maximum height. At this point, ball V was then 3v meters per second. Now we have three sets of information. We can then continue using this equation because now we have our initial velocity, we have our final velocity, we have gravity that is always constant, and we have time as given by the question, by the previous question 3.1. Once we fill in all of this information, we substitute all of the information into its relevant positions. We then bring over v to this side, and then it becomes 3v minus v, and it gives us 2v. On this side, we substitute 1.22 into our time, and when we multiply that out, it gives us 11.956. When we isolate v and we take 2 over to that side, then v is equal to 5.98 meters per second. With the final question, they say that at the instant stone A passes its initial position on its way down, stone B hits the ground. Calculate the height h. As you can see, we have calculated that when A reaches its maximum position, it took 1.22 seconds for it to reach that position. And for it to get back and reach its initial position, it has to take another 1.22 seconds. That is just logic. So we just derived that. There is no equation for that, don't worry. When we look at ball B, we see that as we have decided or calculated, after 1.22 seconds, the ball reached this position over here. And after another 1.2 seconds, so when this ball went from here to here, another 1.22 seconds, the question says that in this time, it then reached the ground. So we can then safely deduce that it took 1.22 1.22 seconds to get from here till here, and another 1.22 seconds to get from here till here. That leaves us with a total of 2.44 seconds. Now we have set of information here. We have our initial velocity that we calculated here. We have our time that we calculated here. And we have our gravity. All you have to do now is substitute this information into your equation, and then that's how you will get the answer. Then you will just isolate your position. If you get stuck, please leave me a comment and I'll make another video giving the answer, or I'll post the answer on my website. The website link you will also find on my Facebook page. Thank you for watching.